good evening. Welcome to this video session. I remain Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we shall continue our study on integral calculus. And in this session, we shall discuss the integration by algebraic substitution. It is one of the methods of integration. Please, you will find a transcript of this video as well as the transcript of the solved examples, the problems we shall do in this video, and other problems. You find it on my website, www.samuelchukwuemeka.com. So you click on mathematics, you click on calculus, and then you click on integral calculus, and you will find the notes and the link to these videos there. Integration by algebraic substitution is a very important method, and it's something that some of the problems in integration, the power rule is straightforward. The power rule is straightforward, but the integration by algebraic substitution, some of them you really need to just do some substitution just to get by. Okay, what you're just doing is still just substituting so that a complex problem can be broken down as a simple problem. Okay, and then you can integrate the function. So we are going to look at the types. Actually, this is part one. This is part one of the video. We're going to do part two by the grace of God. We're going to look at the types of functions, the examples of functions that you can solve with this method. Okay, when you see it immediately, you know, hey, this is going to be algebraic substitution. Now, if your professor gives you a list of standard integrals, okay, you have a list of it, several. I'm adding more on my website. If your professor allows you to use it, okay, gives you the list, then that's good. Okay, that's good. We're going to work how, some of those integrals in that list were got by algebraic substitution, and we're going to look at those also in this video session. If your professor gives you the list, that's okay. Okay, if not, it's still okay. So, what I would like you to understand from by the time we finish this video is to be able to look at any integration problem that you can solve by algebraic substitution, and yes, this is going to be solved by algebraic substitution. And then you know what to substitute, because it is not just knowing that you can solve it by algebraic substitution. You have to know what to substitute. Okay, sometimes you have to figure it in your head. Sometimes you have to just play with it and substitute it, and you hit a stagnant point, you can't move, then you now try another substitution. Okay, but you don't give up. Okay, you do not give up. All right, so we are going to start with simple problems, and then we look at some more problems. Let's start with some standard integrals first. Let's start with some simple standard integrals. So let's say we have integral f of x times the f prime of x dx. So when you have an integration problem where you have the product of the function and its derivative. Okay, by the way, before you start this, it is my expectation that you know your derivatives. Very important. Okay? That you know the derivatives. Very important. You have to master derivatives first before you do integration. Okay, so it's my expectation already that you have mastered, that you know at least, you have at least a good knowledge of derivatives. So if you have when you have the product of the function and the derivative of that function, and you're asked to integrate it, you use algebraic substitution. Like, we're going to list all the ways where you have to use. You look at it, you know, hey, I'm going to use algebraic substitution to do it. Okay. So how do you do this? How do you do this with algebraic substitution? Let me call this number one. How do you do this with algebraic substitution? We say let something like p. I'm going to use p. Okay, I like to be positive. P be f of x. Okay. So the p dx. The p dx is f prime of x. That's the derivative. That's the derivative. Then you now do the x, the p is 1 over f prime of x. Do you see what I'm doing? So the x is the p over f prime of x. So with algebraic substitution, number one, you have to substitute something. Okay? And then you ask me, what do I substitute for a variable? You have to substitute something in the problem for a variable. Now you ask me the question, what do I substitute? And how do I know what to substitute? No problem. By the time we solve more questions, you can look at it right away and say, okay, this is what I'm going to substitute. Okay, so don't worry. Don't worry. Knowing that is with time. By the time you solve more problems, okay, we are going to look at the several cases. Then you can now know. Okay? Sometimes we'll look at several cases, and I will show you. I'll teach you how to know. Okay. So you will have to substitute something. That is why we call it algebraic substitution. Then you find the derivative with respect to the variable, okay, of course to the independent variable, which is the x. So the p dx is f prime of x. Then you find the x dp, because the goal is we want to substitute for something here, and then we now want to also find this dx. What is the x? Based on that new variable we substituted. Okay? So we find the p dx, we find the x dp, then we find what is the x. That is the way we are going to solve all algebraic substitutions, all of them. When we do some substitution, we take the derivative. Then we find the dx. That's the way we do algebraic substitution. Now after that, we now substitute. So this will now be integral of f of x is our p. So p times f prime of x times d of x, dx. Our dx is the p over f prime of x. So times the p over f prime of x. Now we have this, we cross out. Because when you do algebraic substitution, you are doing it so that something will cross out. Normally, Not every case, but normally, the main goal of algebraic substitution is to simplify the problem so that you can just integrate. And when you do that, something is expected to cancel, okay, to cross out, just like this now cancels out. However, there are some trick questions, okay, we're going to look at those later in this video, that it might not cancel out and you can still solve it by algebraic substitution. There are some questions like that, okay? So, but in most cases it's something will cross out. But it is not a hard and fast rule, okay? There are some questions that it must not cancel out, okay? But the main goal of it is to simplify a problem so that it's easy to solve, okay? Now, so now we now have p dp. We now have integral of p dp. And this gives us what now? This gives us p squared over 2 plus c. Of course, the power rule of integration. Okay? So, I mean, if you want me to show all my work, p1 plus 1 over 1 plus 1 plus c. So this is p squared over 2 plus c, which is now f of x all squared over 2 plus c. So this is one of the one of the standard integrals. You have the list on my side. F of x, f prime of x, dx is f of x all squared over 2 plus c. Yeah. If your professor gives you this, that's fine. If not, still no problem. Okay? But at least if you see this, you now know that we got it through algebraic substitution. Now, you will always, okay, you will always substitute back. So you do you do a substitution here, then you find the value of the x, then you substitute it in the main problem, then after that, you substitute back. You've got to substitute back. You were given problem in x. Your answer should be answer in x, not p. Okay? So, let's look at an example of what we just did. Let's look at an example. If I say integral of sine x cos x, yeah, sine x cos x dx, okay, sine x cos x dx. Now we know that the derivative of sine x is cos x. We know that, right? We know that if y is equal to sine x, then dy dx is cos x. We know that. Okay? So, this, of course, looks like this right away. So, of course, your y, it means the f of x. This means that f of x is the sine x. So, f prime of x, the derivative is cos x. So, the answer to this, of course, is sine squared x over 2 plus c. Right away, that's the answer. Okay? This is sine squared x over 2 plus c. That is if we just follow it like this. Now this is handy if you're timed, if you're working on a timed exam, even like in JAM, okay? That's Nigeria, JAM. If you're working in a timed exam, so it's kind of handy, okay? So this is sine squared x over 2 plus c. But let's still go ahead and solve it. Okay, let's solve it. So how do we solve this? We say let P be sine x, the P dx is cos x, the x dp is 1 over cos x. Do you see the format? Do you see each time I am following the format? I do a substitution, then I do the P dx, I do the x dp, then I do the x. The x now is the P over cos x. So technically, we need this here, and we need this. Technically, we need those. That's what we need. Then we now substitute it here. So this integral of sine x cos x dx will now give us integral of P times cos x times the P over cos x. See that? So we go ahead and we cross out this, bam, bam. So we now have integral of P dp, and that is P squared over 2 plus C. And you substitute back. Sine squared x over 2 plus C. And this becomes our answer. See that? That's it. Okay? Now, what if we have something like this? What if we have we still have this? Let me call this number 2 now. Sine x cos x dx. Still the same problem. Okay? Because some people will solve it and will not get this answer. Sine squared x over 2 plus C. And they'll say, hey, Mr. C, I didn't get the same answer. Don't worry. No problema. No problema. So this answer is very correct. Sine squared x over 2 plus C. However, this is another answer that is correct. Okay? This is another answer that is correct. So, you have, you can say, somebody might say, let P be cos x instead of using sine x. Okay, somebody might not know this offhand. You see, number 1. Some people will not know it. Or they might not be given the list of standard integrals. Okay. They might say, hey, let me substitute. Let P be cos x instead of sine x. No problem. So we now say the P, the x, will give us negative sine x. We have the x, the P is negative 1 over sine x. Please, do not put 1 over negative sine x, please. Come on now. This is calculus. This is not algebra, okay? By now, you should know that negative is never in the denominator. It is an abomination. You do not put negative in the denominator of a fraction. That is a taboo in mathematics. Okay? So this will be negative 1 over sine x. So the x is negative the P over sine x. Okay. We need this guy. And we need this guy. So this will be integral sine x times P times the x is negative the P over sine x. Okay? Alright. It cancels out. So we now have integral of negative P dp. And that will give us negative 1 integral of P dp, which will give us negative P 1 plus 1 over 1 plus 1 plus C, which is negative P squared over 2 plus C, which is negative, you substitute back. So this is negative cos squared x over 2 plus C. Okay, this is still correct. So you will have, this answer is correct. This answer is correct. It doesn't matter. It does not matter. Now you might ask me, hey, Mr. C, why? I mean, they are not the same. Technically, they are the same. Okay. How? It's not the same. Sine squared x is not the same as negative cos squared x. Okay. I hear you. Now, let's do what? Let's get back to trigonometry. Okay? Now, remember, and you asked a good question. Good. Because I want you to understand mathematics. We don't want to memorize. We want to understand. Learn it, understand it. Okay? Comprehend it. Okay? So, remember in trigonometry, the Pythagorean identity. One of the Pythagorean identities, okay, and if you go to trigonometry, you will see my notes and videos on trigonometry. One of the Pythagorean identities is this. Actually, the number one Pythagorean identity. Sine squared x plus cos squared x is 1. Okay, so sine squared x is 1 minus cos squared x. Alright, so now when you have this now, sine squared x over 2, like this here, the first thing we got. So this is 1 minus cos squared x over 2. Let me write plus c, plus the arbitrary constant. So you have sine squared x over 2 plus the arbitrary constant is equal to 1 minus cos squared x over 2 plus the arbitrary constant. So this gives us 1 over 2 minus cos squared x over 2 plus c. So this gives us minus cos squared x over 2 plus 1 over 2 plus c. Alright, you see this here, 1/2 plus c is still a constant. Okay, when we do differential equations, you will appreciate, you will understand, you will see, we'll be using this a lot. When you have 1/2 plus c, okay, it's still c, it's still a constant. You're not forming a new constant out of it, no. It's still a constant because the arbitrary constant covers all possible things that might be constants. Okay, so when you also have add 1/2, it still covers it. So that is why you still have this. It's still the same thing as c, and it's the same thing. Okay. All right. Now let's look at another one. So we've looked at this. Okay. Let's look at another one. We can another thing whereby you have to use algebraic substitution. Okay. So anytime it looks like this, even though even if because you look at this here, you see that you don't have minus sine x cos x, okay? You can still use that algebraic substitution. If it's just missing negative, you can still use that. It doesn't matter. So anytime you have something like this, you use algebraic substitution. Okay. Let's look at another case where you use algebraic substitution. All these cases, you know, like a list of the whole standard integrals, I write it on my website, and I'm still adding more, okay, to make it easier. Assuming your professor gives it to you, or if you need a quick reference, okay. Another one, number 2, if you have something like this, f prime of x over f of x dx. Okay? When you have a integration like this, you use algebraic substitution. You do. If you have integration problem that looks like this, okay, whereby you have a fraction and the numerator is the derivative of the denominator. Okay, if the numerator is the derivative of the denominator, you use integration by algebraic substitution. So let's look at that. We'll say let P be f of x. The P dx is f prime of x. We have the x, the P is 1 over f prime of x. So our dx is the P over f prime of x. So this is what we need, and this is what we need. Okay? So this means here, we substitute, this is now f prime of x all over P times the P. And the times the x. But we substitute for the x. The x is the P over f prime of x. Alright, we now cross out. So we now have the P over P. Right? And of course, you know this is, you know, the when you have the P over P, it's ln P plus C. Okay? Power rule. Ln P plus C. So you still substitute back. So this is ln P is f of x plus C. So let us write it here as number 2 here. So number 2, if we have f prime of x over f of x dx. So this gives us ln f of x plus c. That is a standard integral. Alright, let's solve a problem on this. Let's solve a problem that we can use with this. If we have to find integral of tan x dx, tan x dx. This already, of course, tan x with the reciprocal identity with the quotient identity of trigonometry. This is sine x over cos x dx. Okay, we see here, you know what, we're gonna come to this. We're gonna come to tan x, but first of all, let's do the one that looks exactly like this. Okay, so let's do cotan x dx. So this is 1 over tan x dx, which is your cos x over sine x dx. Okay, so this cos x, this looks exactly like this. And don't worry, we are going to come to this. We shall come to it. Yeah. But let's do this first. Okay, now we now say here, let P be sine x. Yeah, anytime you have it such that the numerator is the derivative of the denominator, then you have to do the substitution to be the denominator. Just like we did here. Just like we did here. Anytime you have it such that the numerator is the derivative of the denominator, then you substitute the variable to be the denominator. Okay? So the p dx is cos x. The x, the p, is 1 over cos x. So our dx is the p over cos x. Okay, we have this. We have this. Now, this now gives us, cos x over p times the x. The x is the p over cos x. So we have the p over cos x. And then we cross out. So we have integral of the p over p, which is ln p plus c, which is ln sine x. You have to substitute back plus c. That's the answer. Okay? And then we will now do this one. Now, if you have something like this, okay, this will be this. If you have negative f prime of x over f of x, the x, then you just have negative ln f of x plus c. So this will just be negative cos x, negative ln cos x plus c. Okay, now let's do it. Let's do it, okay? When you have something like this. So I'm gonna erase this. Let's do that tan x. So we have tan x dx, and that is sine x over cos x dx. So we now say let p be cos x, right? The p, the x, is negative sine x, right? The x, the p, is negative 1 over sine x. So our dx is negative the p over sine x. Alright, I'm going to, this is what I need. So this will give me integral of sine x over p times negative dp over sine x. See that? Then I cross out. So I now have, this is equal to negative dp over p, which is negative 1 dp over p. See that? Which is negative ln p plus c, which is negative ln cos x plus c. That's it. Okay? So anytime you have these cases, you know you have to do it algebraic substitution. Alright? Okay. Another one. Let's do more. Let's do other. We're gonna look at several cases. Okay. And we will, we have this, this will have another part. Yeah, because this is, this algebraic substitution is very important. Very, very important. Muy importante. Muy importante. Muy importante. If we have a case like this, okay? If we have a case like this, and I'm mixing up all the functions, okay? I know I've done trigonometric, but I'm going to mix up several functions. Anytime you have a case like this, you're going to use algebraic substitution. If you have a case like this, number 3, integral of e kx dx. You have to use algebraic substitution. Where k is a constant, of course, k is a constant. K is a constant. Okay? So, and it could be positive constant. I mean, I'll just call it a constant here, and later we'll do e negative kx. Okay? So, if you have something like this, you will have to use algebraic substitution. So we now say, and what do you substitute? You say, let p be kx. Let p be kx. Okay, now this is a case whereby it will not cancel. Like I said, it must not cancel. It must not cancel. It must not always cancel. You just want to do some substitution to simplify the problem. Okay, p is equal to kx. We do dp dx. That gives us our k. We do the x dp. That gives us 1 over k. So our dx is dp over k. So we need this. I am using yellow chalk to circulate what I need. So this now will give us integral of e p times the p over k. See that? E to the p times the p over k. Okay? And that gives us 1 over k integral of e p dp. And that gives us EP over k plus c, because integral of e to the p is e to the p. Okay, so this is now e, you substitute back kx over k, e kx over k plus c. Okay? So I'm going to write this as number 4. Number 4, integral of e kx dx, where k is a constant, will give us e kx over k plus c. Okay. And please write this down, and you can also, I will also write it on my, it will also be in the transcript on my website. Now, can you pause the video at the moment and do this one? Okay, can you pause the video at the moment and try this one, then we can look at some examples. Number 4, if we have e to the negative kx dx, where k is a constant, can you just pause the video and tell me what this will be by algebraic substitution? Try it. Try it and tell me. Okay? Pause the video and do it. Do it. Okay, so request. Please do it. Command. Do it. Request. Please do it. Command. Do it. Do it. Do it. Okay. So this will be let p be negative kx. If you put the substitution as p to be kx, you are just messing things up. And Americans will say, don't screw it up. Don't screw it up. Are you taking screw are you taking screw? Folks, and Americans will say, hey folks, don't screw this up. Don't screw it up. If you do P, you see, substitution, you have to look at what do you have to substitute so that when you know, if you substitute, because some people will say, okay, this is the, why don't I substitute let P be kx instead of negative kx? Okay. If you, and that's a good question, by the way, if you do let P be kx, you will end up having e to the negative p. And e to the negative p, you know, it's not straightforward. You still have to, that negative is a problem. The negative is a problem. So substitute it so that when you're substituting back to find the integral, it's not going to be a problem. The negative is a problem and k is a problem. That's why. Okay? And you know, when we do more, sometimes you will, if you have substituted p equal to kx instead of negative kx, you will find out that you will be stuck here. And please, I hope e to the negative p, the p is not e to the negative p. No! That is not what you learned in derivatives. No! No! No. Okay? So, you have to use this substitution here. So, the p dx is negative k. The x, the p, is negative 1 over k. Please, I hope you did not write 1 over negative k. Because you're finna make me mad now. Okay. Alright. Now the x will be negative the p over k. So we're going to use this, we shall use this, and we shall use this. We want to substitute in a way that is easier for us to solve. That is the essence of algebraic substitution. So this will give us integral of e to the p. Okay? Because integral of e to the x dx gives you e to the x dx. Okay, from derivatives. and then from power rule, from the basic integrals, we know that, okay, of derivatives and integrals. We know that. Okay, so that's why we want to make it easier for us. Then times negative dp over k. So this gives us negative 1 over k e to the p dp. Okay? Which gives us negative 1 over k times e to the p plus c, the arbitrary constant, which is negative e to the p over k plus c, which is now negative e, substitute back, p is negative kx over k plus c. That's it. And I will write this as number 5. Number 5, integral of e to the negative kx dx is equal to negative e to the negative kx over k plus c. Right? Okay, let's kind of do 1 or 2 examples, then we move on about this, and then we can move on. Excuse me. If you look at e to the, now let me show you something though. Let me show you something interesting. If we have e to the 2x, e to 2x dx, and if I ask you to do this 2 ways, can you solve these 2 ways using the 5 things we listed already? Like using the 5 things we listed already, can you solve these 2 ways? Can we do that? Okay, so if the first thing that comes to your mind is number 4. Okay, when you have e to the 2x dx, then you look at, hey, number 4 is what I'm gonna use right away. Okay, you use number 4. If you use number 4 says that e to the kx dx is e to the kx over k plus c. And of course you have here that k is 2. K is 2, so this means this will just give you e to the 2x over 2 plus c. Okay, that's the quick way. That's the quick way people would use right away. Because here, if you compare this with this, then you see that k is 2. So that's the quick way that people will use, right? Okay, but let's still do it, let's do it with number 1. How about we do it with number 1? It will still work, and then we'll just do it normally, like as if we don't have these standard integrals. Okay, if we do it with number 1, so this is 1, this is one of them. I'll put asterisk, one of them. Another one, we can do it like number 1. F of x times f prime of x equal to f of x all squared over 2 plus c. Okay, how do we do it with number 1? Oops, I missed that. Okay, how do we do it? But I am still a good basketball player anyway. Okay, how do we do it with number 1? E2x from your law of exponent. This is ex times ex dx. Remember, this is ex times ex because this is ex plus x. Okay, like this is what I mean here. This means 2x. This means ex plus x dx, which is ex times ex dx. And of course, you know that the derivative of the exponential function. Okay, the exponential function is the function that its derivative is the same as the function. Its integral is the same as the function. Its derivative is the same as the function. Its integral is the same as the function. So this is e squared x over 2 plus c, which is still e 2x over 2 plus c. The same thing. I mean, this is like saying ex all squared, because this is ex all squared over 2 plus c. Not e squared x, I'm sorry. Yeah. Because f of x in this case is e to the x. So f squared x is ex all squared plus c, which is, of course, with your law of exponents and logarithms, x times 2 is 2x. The same thing, as you can see here, the same thing. Works. I mean, we used 1 and we used 4 for this, and it works. See that? Now, but let's go ahead and still do it normally. Okay, so because I want you to understand and you know to be conversant with the with this method, algebraic substitution. So let's do this normally. So if we do it normally, e2x dx, okay, we still have, let p be 2x, the p dx is 2, the x dp is 1 over 2, the x is the p over 2. You see, I am not skipping any step. I am showing all steps. I am showing all my work. See that? Okay? So, you must not behave like me. Okay, but if you're still learning this topic, I advise you not to skip steps. If you're still learning it, it will be good not to skip steps. So this will give us now e to the p times the p over 2, which is 1 over 2 ep dp, which is now 1 over 2 e times ep plus c, which is e to the p over 2 plus c, which is e to the 2x over 2 plus c. Okay, we've done this like 3 ways. This is showing all the work, and this is just using standard integrals, 2 different standard integrals. Okay? Alright, we've listed 5 standard integrals. Another one whereby you use algebraic substitution is this one. Okay, let's do more. Number 6. Okay. So as you can see, number 4 and 5, you didn't cancel out. Nothing cancelled at all. Numbers 4 and 5. So it must not cancel. Alright. Let's do number 6. Another one. standard integrals. So number 6, if we have integral of a linear function ax plus b raised to power n dx, where a, b, and n are constants. A, b, n are constants. Okay? A, b, n are constants. Okay? So this will be, you know what, actually you can actually put this to be a plus minus b. It will still work. Okay, but let's do that. So now, we now say let, if you have something like this, we have, let p be ax plus b. For now, let's just put ax plus b, that's fine. Or let me put plus minus, it doesn't matter. Plus minus. Okay? It could work with plus, it could work with minus. No problem. Okay, let me do that. And if you want to do it, first one do plus, second one do minus, that's good, that's fine. It doesn't matter. Alright, so the p, the x, will give us a. Because that's why plus minus b is gone anyway. The p, the x. I don't want to confuse you, okay? Let me just do plus. Okay? And then if we have, after that, let me just finish with plus. I don't want to confuse you. Okay? So the p, the x is a. The next thing, the x, the p, is 1 over a. So our dx is the p over a. I will circle this. Oh, sorry, not this one. I will circle this. I will need this. And then I will need this here. The first and the last one here. Okay, so now I have this. This will give me p raised to power n times the p over a. The p over a. You see that? P raised to power n times the p over a. So this gives us now 1 over a integral of p raised to power n the p, which is 1 over a times p raised to power n plus 1 all over n plus 1 plus c. Plus c, we put the arbitrary constant. So this will now be p raised to power n plus 1 over a times n plus 1 plus c. There you go. And that gives us number 6. That gives us number 6. Okay? You take it down, number 6. So when we have ax plus b exponent n dx. So this gives us, oh sorry, you know we've not finished because this is p. It has to be in x, okay? We have to substitute back. So this will give us now ax plus b raised to power n plus 1 over a times n plus 1 then plus c. So this gives us ax plus b raised to power n plus 1 times a all over, all divided by a times n plus 1 plus c. So this works for plus minus. All you need to do is to put plus minus here. That's it. That is it. I mean, this is what I'm saying. if I don't remove minus. This is what I'm saying. If you have number 7, integral of ax plus b, ax minus b exponent n dx, this will give us ax minus b exponent n plus 1 all over a times n plus 1 plus c. So this 6 and 7, you can put it in compact form by just doing plus minus. That's it. That is it only. Gives us the same thing. Okay? Right? Okay. Now, let's do an example of this. Let's do an example of this. Let us do an example of this. Number 6. I have a question here. Integral of 7x minus 3 all raised to power 5. Integral of 7x minus 3 all raised to power 5 dx. So, we're doing this step by step. If we just use standard integral right away, and then we'll solve it normally, okay? Because some people will not be given this. Some people, your professors will not give you this, okay? But if we compare, to the standard integral, compare to integral of ax minus b exponent n dx. So our a is 7, our b is 3, our n is 5. Okay? Our n is 5. So we need n plus 1. So our n plus 1 is 5 plus 1, which is 6. And then a times n plus 1 is 7 times 6, which is 42. 42. Right? So the answer to this is 7x minus 3 all raised to power 6 over 42 plus c. This is our answer here. That's our answer. That is our answer. Okay? Yeah, but let's solve it normally. Let us solve it normally. Okay? So when we have 7x minus 3 raised to power 5 dx. So we now say let p is 7x minus 3. Yeah, anytime you have something like this, okay? And please, even if they put 2 or 3 here, some people will go and maybe if they put 2 or 3, they will try to expand the binomial. Of course, but when they put 50 or 100, you cannot go and start unless you're going to use a binomial expansion formula. Come on. Doing algebraic substitution. Okay. So let p be 7x minus 3, you use this. The p dx is 7. The x, the p is 1 over 7. So our dx is the p over 7. Alright. So, folks, this will now give us integral of p to the 5th times the p over 7. So this is 1 over 7 integral of p to the 5th dp, which is 1 over 7 times p to the 6th over 6, because this is p 5 plus 1 over 5 plus 1. Okay? Power rule. You know the power rule of integration. Then plus c. So this is p to the 6 over 42 plus c, which is now, you substitute back, which is 7x minus 3 raised to the power 6 over 42 plus c. Okay. We are going to stop here tonight. Okay, we shall stop here tonight. But this is your assignment. Okay, your assignment, and then you can check it on my website. You can check the solution on my website. Just a simple assignment. I want you to give me the standard integral for this. Give me the standard integral for integral of negative a plus minus b raised to power n dx. So what we just changed is the a instead of a, negative ax plus minus b. Okay? So instead of the ax, we change the negative ax. You will still solve it by algebraic substitution. But I want you to find the standard integral for it. Okay? And check your work with my work on my website. Alright? This is part 1. Part 1. We still have several, but you know, I'm starting with the simple ones so that you will have a good understanding of it. Then we now solve more. We solve more challenging ones. Okay. So do this one. Okay. And if you want to do it twice, you know, negative ax plus b, negative ax minus b, no problem. Okay. But it's still the same. You will still have the same, you will still have, not the same one, but similar, just like we have here. Okay, but I want you to do it well. It's not going to be this. You see, this is negative a. The coefficient now is negative a, not a. Okay. Because I could put negative 7x there. Okay, so do it, and then check your solution on my website. Thank you so much for listening, and you have a good night.